is an entity. Actually, what we are going to do is finding entity types. But as I mentioned, the entity or entity types interchangeably. I'm going to use a mix up. So when I say entity, that means entity type. Okay, but you should be recognizing the difference between the entity and the entity type, also entity set, and so on. So for example, in case of the company database, so we have the department, and also we have the employee, so we have dependent, and we have the project. As we discussed, there is no general answer or perfect answer in the conceptual level modeling. Depending on how to understand, how you guys understand the information, it may be different. Also, we need to consider user requirement and the data itself. So this is just for practice, and mostly I got rid of any ambiguous thing or vague information, but clear thing like the department, employee, project, and this one. Also, we are going to use the diagram, which is called the EI diagram. So for example, to represent the entity type, we are going to use the rectangular, like this one. So it's not standardized. There are many different ways of such a diagram notation. So sometimes we can use the Crowfoot style diagram, or we can use the UML style diagram. This is one notation used by the textbook I'm going to use. But most of such a diagram, intuitively you guys can understand. So it's not a big deal to catch up. So don't be confused when you are using the Irwin software on the Thursday in this classroom. So that Irwin, the data modeler, uses slightly different notation. You can select 2 or 3, among the 2 or 3 different notation you can select, but intuitively you guys can understand such a difference. It's not a big deal. So in this case, in this example, we are going to use the textbook, the notation. I cannot remember any specific name on that the diagram notation, but you can understand. But for your project, it's you can use any notation. Okay, as long as you are using software or tool, it is fine, except the handwritten. Okay, do not draw the EI diagram using the pen, then take the photo will not be accepted. Okay, otherwise, based on your preference, you can use any other notation. Then the second step is we need to find what? Attribute. For example, the department has the name and the number and the manager and start date as many as possible. The employee, we have the social security number and the name and so on. So at that time, we can move over and connect it to the corresponding entity. So we can find as many attributes as possible. So there are different types of attributes we can identify. So first thing is a single attribute. Single attribute is like this one. Name is one attribute, one value. And the number is one value, one attribute. There is a composite attribute. Composite attribute means, for example, the address. Address consists of the street number, street name, and the city name, and the state name, and zip code, like this one. So one attribute consists of a number of the other attributes. So this is called a composite attribute. In case of a composite attribute, you can use such a 3-style notation. You guys can easily understand. But how do I decide whether this is a single attribute or a composite attribute? Another example is the name. Name can be the first name, the last name, also middle name, initial. So which one is better? The single or composite? It depends on your decision. When you decide such a type of attribute, take a look at the data and application. So if you go to the first page of the handout, we have the left-hand side is application analysis that you have learned in your software engineering. But we are going to add the database design part, the right-hand side, the flow. They are interactively work together, which means sometimes when you decide the conceptual modeling, you need to take a look at the application analysis. Typical example of such an address is if you sign any website or the service, some of the menu just ask your full address in one text box. On the other hand, most of them use the address number 1, address number 2, the CD, and the differently, because later they try to use your CD information or the state information, zip code information separately. So it depends on your application analysis. Okay, so then also we have the multi-valued attribute. Multi-valued attribute is for example, location of the department, unlike the location of the project. This is a singular, this is a product. In case of product, we should identify, which is not very important in object-oriented concept. In OOP, it's not a big deal whether it's a single value or multi-value. However, in relation, not the ER modeling, but the problem is that later, relational database modeling. Relational database modeling cannot take care of such a multi-valued one. So we, during the conceptual modeling, we are going to identify such a multi-valued one. So one more thing is we are going to find the key attribute. Key attribute is the unique value. In other words, if I can use such an attribute to search the specific entity, that is called the key attribute, like the unique name of the department, unique number, and the social security number. So whenever you find such a unique value of attribute, you can define as the key attribute. That means sometimes we have multiple key attributes. It's totally fine because this is a conceptual level. However, if you know the little bit about, or if you have experience on database, you may be confused. Database allow only one, the primary key. Okay? There is another key, secondary, so there are multiple keys, but only one primary key in database. Foreign key is slightly different, so we will see later. Okay? The primary key is the only one. So, but during the conceptual modeling, as many key attributes as possible. Okay? Among them, we are going to select one, the key attribute as a primary key later. So sometimes it may not have the key attribute instead the name. Maybe used, but it's not the really unique. Instead, we need to use the other attribute, other entity. This is called the partial key. So in case of partial key, we can use the dot line because eventually later we will use such a thing. Then third thing is entity and relationship. So relationship, same thing. It's actually type, but we are going to use it interchangeably, the relationship and relationship type. So, for example, department, control the project, and manage, and also work for, and head, and this is hours work on, and also we have the supervise, like this, as many attributes as the relationship as possible. Okay, there are different types of the relationship. Cardinality, so one to one, one to many, many to many, the type. If you are not sure what is this, remind the elementary math. So we have learned about the situation one-to-one mapping, one many-to-one mapping, or many-to-mapping, exactly same thing. So for example, the many employee works for one department. Okay, one department has many employees, so it's a many-to-one relation. Don't be confused. So if you draw this as the Venn diagram, like this one, this is a department, this is an employee. So one department, like this one. This is the example in terms of mapping. So it looks like the many-to-one. Okay, but this is the opposite. Many element, the map to the one, the element of department. I got confused also when I was a student. So I always remember only one. Many employees works for one department. Then the many-to-one is clear. Later we will clarify the more details of this one. At the end of this class or maybe the Thursday class. So many to one. So manager is one-to-one. We have only one. And also the one department control many projects. And one employee has many dependents. Also the one supervisor, the supervising the employees, like this one. So this one is many to many means. So like this, the project and employee. One employee works on the many projects. Also, the many employee works on the one project, which means it's a many to many relationship. If you read the requirement carefully, the one employee works on the many projects, then number of hours. So for example, employee 1 works on the project 1, 10 hours. Employee 1 works on project 2, 20 hours. Something like that. So we need to manage such a number of hours. Project side, employee side, no. So we can create the hours attribute for the many-to-many relationship. So the relationship also has this is a cardinality, and this is the attribute. You can find as many attributes as possible. Sometimes one-to-one may have the attribute, like the start date. So start date, in case of one-to-one, because it's a one-to-one mapping, this start date can be department. This start date can be attribute of the employee. This start date can be attribute of relationship. It doesn't matter. But if you think a little bit more, it may be the attribute of a department. Why? Not all employees are managers. Okay? A lot of them are non-managers. So we don't use such a start date for the non-manager, the employee. So we can keep the start date this side. But later we will take care in the relational database modeling. But to conceptual understanding, it's not a big deal. Okay, then the last one is the weak entity. Weak entity is this. So in case during the conceptual modeling, weak entity is not a big problem because it's conceptually just organized. However, later when we are doing database modeling, it's a problem. Later we will see the one big requirement of the relational database model is each table, each relation, each whatever should have the one primary key, at least one primary key, because without key, we cannot identify, we cannot find the data. If you remember the main purpose of using database, searching data very fast. Okay, best way, using unique value like the UBID or social security number. If data are conflict or duplicate, it will be very tough. It will be very hard to find such a data. So this is okay during the conceptual modeling, but later this is a problem. So we try to find something, the unique value. How can we identify the dependent? We need to know who is the employee. So this is called the identifying relationship. So double the numbers. And the double line means, so we have a single line, double line. Double line means it's mandatory. This is optional. For example, department must have the manager. However, employee, not all employee are not manager, like the single line. This should be double line because if there exists any dependent, meaning should be employee. Okay? So this is the identifying relationship. This is the double line. And we can use the rectangular to represent a weak entity. So this is our first example of ER diagram. Also, this should be your homework, if you remember. So please submit the homework before you leave here. So that can be also considered as the attendance. So if you forget the homework, don't waste of the class hour. Just mark your name and ID. Then at least you will get the attendance. Any question for this ER diagram? This is a simple one. Okay. However, understanding the ER diagram is not a big problem. The problem is experience. So we cannot study and practice every day, every time the ER modeling only. So instead, I'd like to give the student, you, the opportunity to practice more and more. At least we did this one and the university, and also you are going to do the homework. I'm not going to remind the homework every time. So it's already scheduled on Canvas. So you can, if our class schedule is behind such a homework schedule, the GA will adjust the time. So, but otherwise you need to submit your homework. The homework is another one. Then not many. Because of that, so every semester I'm going to ask each student find any sample database description. So you can use the internet, you can use the textbook, you can use anything, any source, or even you can create your own database. Not too big. So this is one of the example. So why don't you? So this is an example of the spring 2017, 18 in the classroom. One student like a hospital management system. So then you guys can create the database description. It can be bullet, it can be the statement, it can be whatever. No longer than the half page. Okay? Not too long, very simple. Then draw the ER diagram in the page, like this one. So why don't you get up? Why don't you give the handout to the student, the last, and submit on Canvas by the Sunday, okay? Monday, next week, Monday, yes, Monday, okay? So any topic that the database description, half-page description, half-page ER diagram. This is one of the submissions. Then I'm going to select one of the, not the best, reasonable, and also doable, one of the submission as your midterm exam. So this is one example. I actually asked the question of drawing the ER diagram in the midterm of the spring 2018. So if you are lucky, the homework will be selected as the midterm. That doesn't mean you will get the full credit. Sometimes, even though you submit, you forget the answer. So then at least we have the 30. I know some of the students will submit the duplicate one, but at least we have the 10 to 15, the reasonable, the ER diagram. So you guys can practice for your midterm exam. This is a good example of study. So today we are going to solve another problem of the hospital management system by following the steps mentioned here. Okay, I will give the 3.5 minutes to understand the description. Why don't you read carefully? Yes. Yeah, on Canvas. Yeah, soft copy. Because I'm going to compile all your submission into one PDF version, then we'll share. So because of that, I need the soft copy of your submission by the end of weekend, Monday. Weekend will be better. So by Sunday evening. This Sunday evening. Okay? Sunday evening. Coming Sunday evening. Monday? Which one is better? The homework. Monday? Monday? Okay, Monday. Whatever. But for right now, this is an example. This is for your practice right now. So read carefully the description. 3.5 minutes. Yes. Yes. Why don't you read the description? This is the base amount you need to submit. This is another one. I'm going to credit card. There's no return. Why don't you? If you go to the canvas, I think you can find the last year's example. Not sure whether I posted it or not. And also, some of the students just copy and paste and doesn't make sense any the answer or the something. You will get just the minimum credit. However, if you spend the time, if I realize your effort, then I will usually give the extra points because you helped me to make a question of the midterm exam. Also, this the EI diagram later you will see that will be useful eventually throughout the semester. So your midterm, actually 60% of the midterm will be come from the question selected, the ER diagram. Okay, so let's take a look at this question together. In this, the hospital management system is right to keep track of the information about the hospital. So each department has a unique name, unique ID. The room and the doctor who manage the department, we track the start date of the head. Very similar as company database. The information of the doctor's name, the unique doctor's ID, gender, contact, and the doctor's working department name are stored. Each doctor works for one department. Each doctor has several assigned patients. So which means that we may expect something patient information later. Each the receptionist has a name, unique ID, contact info, and the register several the patient. The receptionist maintain the record of the patient appointment. The record consists of the unique record number, unique and blah blah blah. Each receptionist register several the patient and also the maintain several record. The patient information such as name, unique ID, and DOB, a number of the contacts can be stored, so which means multiple. And each patient may be assigned by the several doctors. So in addition, the first date of assignment can be stored between a doctor and patient. So it's not the better than the company database description because not many students know such as the hospital system. Also, it's a little bit vague. It's not the general description. So we are going to use this description to create the ER diagram. So first thing is to find the entity. What kind of entity type can you find from the description? First, we have a department. Very clear. What else? Doctor. We have a doctor also. So we have the number of receptionists. Can you find any further information about the receptionist? Yes. So we have the reception. Anything else? There can be the entity. The patient. Okay. Patient record. Patient. And record. Also record. So also we have a record. And anything else? Yeah, pretty much. That can be. So we can later, if we realize that there are some any additional entity type, we are going to discuss. Okay, whether some of the entity can be the actual attribute of others. Okay. For example, even though we have seen the multi-valued one, the meaning, the concept itself is attribute, but it can be considered as the entity, and the vice versa. So we can discuss if we have any, there might be some of the students it's not very clear, so some of the information may be entity. Yes, that's true. So we can discuss about such a thing. But clearly, so we can find such an entity, the type from the description that we are going to manage. What about the hospital name? Hospital itself. This is a one hospital management system. So if we have multiple branches of the hospital, such a branch hospital information can be one entity. But in this case, so we have only one hospital. So hospital itself is the fixed value. We don't have to manage in the database. This is overhead. In our application program or the other, so we can manage such information. So next thing is that we are going to identify the attribute for each. So for example, what the department. Let's start with the department because it's the first unique name. So we have the name of the department and ID, the DID. Sometimes it's not big problem. The ID, or to clarify which ID. So some of the students like to use the D underscore ID, P underscore ID, or patient ID is to totally fine. Okay? So however, even though you are using the ID, later we are going to use the dot notation in database also. Department dot ID. We are going to use such the dot notation to clarify the name of the attribute. So it's up to you. So what? But if I do not understand the ID, like if you just I, you may not get the full credit in this classroom. Okay. So please use the reasonable name. Okay, meaningful name of the attribute, and also we have the room information. Room of the department or the room number, and also we have the doctor who managed. So we already know the relationship. So at this time, we may create something, the manage, the doctor. So this one goes to this. So manage. The doctor managed the department. Who managed the department? We track of the start date of the head. The doctor, so we can create the start date right here. Yes, this one will be better because not all doctors are manager, so we can create the over here.
Can we create in the relationship where we are managing the doctors?
Managing the doctors, the
start date, yeah, in standard.
You mean that this one?
Yeah.
So this is totally fine as I mentioned before. So this is how many managers or doctor who manage the one department. So this is a one-to-one relationship, so we can put the attribute over here. Later, when we create the database, so using the relational database model, this is a little bit tricky part. So that's the reason I do not force to use only this one. So it may be barriers depending on how to create the table. It's totally fine, either this one or this one. So, okay. Similarly, we can create the attribute of the next one is the information of doctor. Let's go to the doctor. So doctor has the ID name. We have a name. So this is a unique name and unique ID. So even though ID is not mentioned as a unique, so we can use the key attribute. So we can identify the key attribute. Doctor's name is not the clear. We cannot use the key attribute right now. And the unique doctor's ID, DID, or the doctor's ID is a unique. And the gender and the contact and doctor's working department is contact. Working department is we have also working department. How many departments in this case? So one doctor works for the doctor's working department. Probably it's one department, so which means it's many doctor working for the one department of the hospital. Okay? Maintain the record of the patient appointment, and not this one. each doctor works for one department. It's clearly mentioned here, and each doctor has the several assigned patient. Has the several assigned the patient, like this one, right? So we have the one-to-many relationship between the patient and the doctor. So let's move the patient first. The patient is the last one. Patient information such as the name and the unique ID. So patient ID will be the key attribute, date of birth, DOB, and the number of the contacts. Number of contacts in this case, the multi-valued one, double over, can be stored. Gender, is it any gender? Yes, gender information. And each patient may have assigned by the several doctor, which means there is a many-to-many relationship. Okay, sometimes the one patient need the internal medicine or the other, the orthopedic and so on. So it's a many-to-many relationship over here. Okay. And in addition, the first date of assignment between the doctor and patient can be stored. Which means this assigned date will be attribute of this one. So I intentionally clarify the first date of assignment between a doctor and a patient, because when the patient come into the hospital, the first the primary physician will be assigned, but later realize that we need more and more the doctors. At that time, such a assigned date will be managed here. So we have a number of assignment date, and also different many the patient. So we can manage such a first assignment date as the attribute of the assigned attribute, the relationship. Okay, so this is a many-to-many relationship and assigned. Okay, then what else? So we have the record. Record consists of the unique record number. This will be the key attribute, and the unique patient identification number. The patient identification number is the patient identification number is this one. So if record is simple, this one can be attribute of the patient, right? And also because each patient has only one record ID. You understand? But this time probably the customer, your customer hospital, give the bunch of the record information that is classified by each patient, right? So one patient has this file, another patient has this file. If we manage this file as an attribute of the patient, there might be a bunch of other information which cannot be managed by the relational database later. So it's a good idea to separate as the attribute, the entity type, then create the relationship between this one. So this can be named as the maintain or the manage. So it's how many
so that
record?
Still stores the patient ID.
This one?
Yeah.
So it has the patient information such as record consists of the unique record number, unique patient identification number. So it's a one ID number that is managed here. But let's see how many records. One patient may have the number of the file, but it's not clear here. Okay? But maybe possible record one file and another file based on something, I'm not sure, but it may be possible, but it's not clear here. So we can say it may be 1 to 1 But it may be possible one to many, but so in this case for safe, I can leave the one to many. Okay? Then it may include one to one. But it's not very clear based on this. Then what other information? And something other information, registration list who assign, okay? ID.
One too many, right?
Patient to
The receptionist will have.
Registration list and the record we may create,
Yeah.
but in this case, I'm not going to create, but we can create. So, assign,
Yeah.
assign.
Or just manage.
So one to many record, okay? The reason is that later we will see such a reception, patient, and doctor may have something different relationship, which is called the ternary relationship. But I do not mention about this one yet, so we will see the later. Because when receptionist assign the doctor to the patient, okay, it happened together, right? So receptionist assign patient to the doctor. So it's the three entities are combined. So we will see such an example later, but this time you can leave such a three. So it's one to many, the record.
we can see
Then the receptionist.
relation with
So receptionist, actually the
registered patient, relation with patient.
maintain, okay. What is the key of the receptionist? Has a name, okay, unique ID. I think the receptionist ID and also name, this is a key. And patient identification number, that means the receptionist has the relationship with the patient, okay? You can see this has the relationship, this has the relationship, this has the relationship. So actually this is the three entities are combined into one.
Because they're all sharing the patient.
Yes. So this is called the ternary relationship. So far we have seen the binary relationship. Entity to entity, entity to entity, entity to entity, two entities. Even though supervisor is the employee, supervised employee, two entities. Okay. However, here, basically three entities are combined. So this can be, so receptionist and patient and record. So three entities, this is assigned, are combined. So this is called the ternary relationship. But ternary relationship cannot be handled by the relational database layer. Okay? Instead, we can create this one. Receptionist, patient, patient to the record, record to the, like this, the binary relationship. Okay, so more information about the receptionist we can add, like the several patients maintain the record of the patient appointment. So patient appointment. So we can have the patient, receptionist assign the patient and the patient appointment is the inside, like this one. This is a love. So another homework. So why don't you finalize this the ER diagram? You cannot finish this one. The love the design of the ER diagram. The rest of the thing is the job as a homework. Okay. So you can draw the final ER diagram and submit by the next week class, the Tuesday. Okay. Next week class, submit this. You can just submit after finish the ER diagram by the next week, the Tuesday class in the classroom. You can submit it. But this is just a rough. This is not the final answer. Even if you have any assumption, so you can add the assumption, because it's, as I mentioned, not always is really clear the description. Okay. Any other questions? So please practice more. And the last thing, you need to focus on your project. Okay? So anyone who is not assigned to any project yet, or you do not know your project partner, please find after the class. If you do not know, come to the podium. Then I will let you know who is your partner. Okay? Okay. So next, let me quickly move to the finish. The chapter 3. We already discussed everything. So ER modeling, the first step is finding entity and their attribute. Okay, and different we have, as we have seen in the couple of examples, we have different types of the attribute: single attribute, composite attribute, and the key attribute, and multi-valued attribute, and so on. So this is the example of the composite attribute. We can use such the three notation. And also, we can identify as many key attributes as possible later. It will help for your database design. Okay, if you do not identify the key attribute right now, later it will be very complicated. So in terms of the database design, it doesn't make sense without the key attribute. Always we must have at least one key attribute in the database. But conceptual design is okay. So we will see later more details of this one. Okay. So finally we have the entity set. Keep in mind the domain. So when Dr. E.F. Code, so Dr. E.F. Code is the guy, the researcher who proposed the relational database design as well as ER modeling. So ER modeling and such a conceptual modeling, actually he and his colleagues are usually, mostly from the Stanford University in 1980-1990. So at that time, the people, the colleagues, so my supervisor, the community member of my PhD, Dr. Emerson, who authored your textbook. Actually, he was one of the members of such a conceptual design group, who proposed the ER modeling. At the time, they actually mentioned about the domain instead of the data type. So domain is, for example, what is the data type? I mentioned last time. Yes.
It's a set.
It's a set. To simplify, standardize. So we have a bunch of infinite number of that, but in computer memory structure, it's a full byte. The memory space. It doesn't matter what is the number, but it's a full byte. In case of floating, okay, decimal point. So we use a floating data type. So it's the two word. So the space, that is the data type standardized. But in conceptual modeling and database design, so they didn't have such a concept of data type. Instead, domain. Domain means if I decide the attribute of a social security number, okay? Actually, when we create the instance, where the entity, social security number, how many possible the social security number? It's not unlimited. It might be 10 digit the number, as long as it's unique. So it's a finite set. Among the finite set of social security number, we can pick up one of them. Same idea for the name. Name, how do you store the name in your computer system? How do you can create, for example, Java string. String might be limitation, like 2K, 4K, or something like that. Then put as many string characters as possible. However, when conceptual level, that is a computer, physical internal level, memory structure. But conceptual level, name is, there are many possibilities of the name. But it's a finite set. It's huge, but finite set. So, what we are going to do is pick up one of the names from all possible the names worldwide. Okay? That is concept of a domain. Actually, domain is the way how to create the instance, sample data. So when they propose the relational database model and ER concept. But physically, it's not possible to manage all possible names in computer system. Instead, we are using data type, like a string, or a character, or sometimes primitive data type, or object in terms of object-oriented concept, it's a class, so we can use. So that is the different, slightly different concept. So just to understand such a name of domain, meaning of domain. Nowadays, NoSQL database use some of the, very rarely use such a domain concept instead of a data type because we are not sure sometimes. One of the example is like the department number, for example. Department number should be always the 111213, for example. So that's it in our university. So no other. It's not 2 digits, only 111213. 3 cases. That is our domain. So you need to always select department number from this the kind of box, jar. So that is called the domain concept. So of the DBMS, NoSQL database use the domain concept of domain instead of data type nowadays. However, so this is the domain. So we have the entity type. This is the notation, as I mentioned. So this is the after step, the 1 and 2, identifying the entity and identifying the attribute, and sometimes the double. Double means the multi-valued one, and the underscore is the key attribute. Then we can identify the relationship. So there are 3 different types of the relationship. So finally, we can have such a nice ER diagram. If you can understand the meaning of this database from the ER diagram, it's mostly okay. But I didn't mention about the one. I probably explained everything except the one. Like this, right? It's the dot over number of employees of the department. This is not critical, but for your information, actually, we can count number of employees for each department, right? It's not actually attribute, but probably the designer of this ER diagram realized there are a lot of the requirement from the menu or function application. Number of the employee for each department. If you do not maintain such an attribute, you need to always, every time, count. Access the employee and count and show the number of employees for each department.
Can you repeat it one more time?
So, for example, when we maintain the department does not have a number of employees. How do you get the number of employees? Using relationship works for access the employee. You can count each department how many. Okay? So if you have the menu to show the department, number 1, how many employees, to show this. Whenever you just click this menu, you need to access this and the count and return. This is a really cost. Why? Because you need to access all the employees. If you have the millions of employees, okay, then it will take a really long time. However, this number of employees will not be changed a lot quickly. Okay? So how many times you hire the employee? Maybe the monthly or so on. So instead, why don't we count one time, then store such a number of employees as an attribute. Then we can save the time. So probably, I guess, the designer of the company database realized that there are many the requirement of number of employees. So we can create such a number of employee attribute. However, this value is not assigned. Instead, we can calculate. So this is called the derived attribute. So sometimes you can create additional derived the attribute to save the computation time later. To do that, you need to fully understand your application. Okay, so this is another thing you can consider. So we have the different types of attribute, the relationship type. So finally, this should be output of your homework. Okay. So then that's pretty much okay. The 95% of the ER diagram. I'm going to add several more things. The first one is the different notation. Because we have seen the three cardinality, one-to-one, one-to-many, many-to-many. However, it's not very clear sometimes. For example, the company policy allow only each department must have at least 4 employees. For example, one is manager, another one is the co-manager, the third one is a secretary, 2 secretaries, for example. So at least 2 form of one department, each department should have at least 4 employees. Can you represent such a policy in this cardinality? No way. Because it's just to show the one-to-one, one-to-many, many-to-many. So to address such the detailed requirement of the conceptual modeling, we are going to use the different notation. This is called the min-max notation. So min-max notation, represent what is the minimum participant for the relationship, and what is the maximum participant of the relationship. For example, actually employee and department is many to one, one to many, right? However, if we this one works for first, many are one to many. But in terms of min-max notation, the first one is a minimum, and this one is a maximum. Minimum, maximum. However, minimum of what? Employees' participation to the workforce. So for example, one employee, minimum 1 department workforce. And maximum how many departments? 1 department. So that's the reason 1,1. Okay? However, for example, if some of the new employee may not be assigned, okay? So if that is your policy, minimum 0 department, maximum 1 department. So that is the min-max notation. From department point of view, this is how many employees minimum? 1, at least 1 manager. And maximum? Many employees. Okay? For example, the company policy minimum 4 employees. Then we can change 4. Maximum 1,000, for example. You can specify 1,000. So min-max notation can specify the details of the relationship. However, the problem is, it's really confusing. It's many to 1, right? In terms of cardinality. However, it's 1,1 and 1,n. So it's a little bit confusing, but keep in mind, min-max notation is from this side. So department side, this. Also, using min-max notation, we don't have to specify optional or mandatory. For example, this is the minimum one, which means mandatory participation. However, manager, let's see the manager. It's 1 to 1. However, if we are using min-max notation, employee, minimum 0 department managing. Right? Maximum how many? 1. Some of the employee manage. The others not manage. In case of manager, 1 department. Okay? So that is the reason 0,1. from department side, how many manager? Minimum 1, maximum 1. So this is a min-max notation. So in your project, if you want, you can use a min-max notation. But in the real, the project outside, after your graduation, most of the project do not use the min-max notation. It's too specified. Okay. Also, such details will not be implemented in the database. But if you need, you can use the min-max notation. This is another ER diagram based on the min-max notation. You can see, for example, works for 4, n means what? Minimum 4 employees for each department. Maximum n. And this is 1, means so employees should be assigned always. At least 1, maximum 1. Only 1 department like this. And the supervision, let's see the supervision. This is the supervisor side. Okay, this is the supervisor side. So 0, n means what? How many supervising? Each supervisor. 0. Sometimes I do not have any supervising. Sometimes number. Okay, number of the supervisor. However, this side, supervisor side. Okay, how many supervisors do I have? Only 1 maximum. But the CEO may not have a supervisor because it's top of the organization. So that is the reason 0, 1. Okay? And this one, weak entity. So should be mandatory. How many employee for the dependent? 1. Minimum 1, maximum 1. However, from the employee side, how many dependent? Sometimes I'm single. I do not have a dependent. But sometimes many dependent. So, right? So that is a 0, n. So this is a different ways of the ER diagram to clarify the the cardinality using the min-max notation. So you feel free to use this one if you want, but most of the case in the real project they do not use the min-max notation. Okay. This is a diagram. Also, you can use, if you really prefer UNA class diagram, you can use. This is an example of the exactly same the database ER diagram that we created, but based on the UNA class diagram. Okay? But actually, I'm not the generation to learn the computer science based on the object-oriented concept. I still not very confident to use the UML class diagram, frankly speaking. So different are the ways of notation. Okay, one of the popular notation in the ER diagram is a crowfoot notation. Crowfoot. Crowfoot is like this one. I'm not very good at any drawing, like the crowfoot. It's a bird. So use case you use this one. So crowfoot. This side probably many side. This one is one side. So 1 too many. We can use the 1 too many using this one. Also, there are a couple of other things. In general, it's not the. Sometimes you may consider, sometimes not. If you draw the ER diagram, you may realize one important entity. Okay? So for example, in case of a company database, department is the major one. All employee, customer are related to the department. Similarly, the hospital is the, for example, doctor or something like that. So you can put this is your paper or the playground to draw the ER diagram. You can put the important one to the top left corner. Okay, then create the relationship like this one, like this one. So mostly important one in the top left. Another way is middle, important one, and like this. This is called the star diagram. So important one is in the middle, then connect the relationship. So many of the data warehousing system uses such a way. Data warehousing, one main, the table, one main entity, and this one. Another thing is the snake side. Like the it's a like the network. It's a connect each other. Okay, like this. So depending on the domain of your database, it may be one of, but probably this one may be okay. But it's not required. It's for better understanding. When somebody read your EI diagram. Okay. During the example of hospital management, I mentioned about the higher degree relationship. Mostly two entities are involved for the relationship, but sometimes it may be possible 3 or 4, mostly 3. So which is called ternary relationship. For example, like this. Let's take a look at this one. Supplier, supply. Supply is the action relationship. Item, part to the specific project. Okay, that may happen. So supplier supply the item to the specific project. 3 entities are involved. This is called the ternary relationship, so we can connect all entity to the relationship. Unfortunately, relational database model cannot represent such a ternary relationship later. Okay? Relational model is very, very strict. It's not flexible. It's old-fashioned, really. So this is not possible. Instead, we are going to, as we have seen the hospital example, we can create binary, 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 like this. Or another way is, why don't we create one entity for the supply and connect. At this time, this one is a weak entity. By combining key of 3. Okay, so two approach. Question. A is what we want. Do you think A is the same as the B? Or A is the same as C? Or not? Looks like very similar, but they are not the same. For example, here, we are going to maintain the part. Only supplier has also supplied to the project. However, in this case, it may be possible. Supplier can supply the part 1, part 2, part 3. However, project needs only part 1, part 2. Part 3 will not be here because it's not being used the project. However, this is too much general. So you may have unnecessary information. It may be possible. But no way in the relational database model. So relational database model uses such a way. Or even though you create this with entity, you may have a lot of parts which will not be used this. Some of them may be used, some of them are not. So when you create intuitively, because we know the little bit database, so we can create this one and this one. However, that may cause unnecessary information when you create the database. So you should keep in mind such a thing. So to avoid that, so we can actually, this is another example of the instructor offer the course for the specific semester. If we do not have this, the instructor, I can teach many courses, but will not be offered. Some of them offer, some of them are not. Okay, so it's different. So we will see such an example, how to deal with when we create a relational database model later. Okay, so that is the end of chapter 3. So for the modeling, there are a bunch of different software. Nowadays, such a software is not only for the conceptual modeling. It's for your software management, entire project. For example, if you create one entity, automatically create, what is some IDE? So think about the IDE. So when you design UML modeling, it automatically creates a class. Right? Then what you need to do is also you create a setter and a getter. and some method, default method will be created. Then what you guys need to do is add your algorithm only. Similarly, when you model this one, automatically create a database. The Orwin software that you are going to use on Thursday also has the function. If you connect the database menu, click and draw the one entity, automatically create a table. Okay? And if you change the model, automatically change the database. So it's kind of a software engineering, the tool. Not only just the database model, but the entire project. Like the rational rows in the IBM is much, much expensive. There's such a software management tool. So Visio is just for drawing purpose, you can use. But except hand drawing. So I'm not going to accept the hand drawing. You can use any other software, but in our class we will use the Orwin software. Okay, then ceremony. Have you ever heard about the deep learning? Deep learning nowadays, AI, machine learning, deep learning. So, what are they?
It's an automatic thing where the machine could able to learn itself and then function according to that.
Right. So why don't we think about go back to our baby or the kindergarten. So how did you learn? So think about how did you learn something?
With information.
With further information. So if you are smart, somebody will give the information when you were 2 or 3 years old. But at that time, usually, do not touch this, your mom said, because it's hot. Okay, like that. Then you don't hear. You don't hear. He tried to touch, but probably sometimes the punishment, okay, you should not, okay. I don't hit, but so keep the mentioning. This is for example, apple, and this is another apple, and this is an apple. Then later, eventually, you realize this is an apple. So this is kind of generalization. So we learn something based on the generalization. So very specific, like when you train the model in the machine learning AI, it's based on the training. How to train? We have case by case data, train data. Then try to generalize to the what? Model. So our goal of such a machine learning is to train the model, to build our model, generalization. Then, that's it. We like to use such a generalized model. Or you said you learn. Probably in your brain, like it's called the neural somewhere, and not neuroscience, but somewhere in your brain. So you have something concept of the apple. So even though you never seen this is another apple. You never seen, but you know this is an apple. How do you guarantee this is an apple? You never seen this one, right? But we generalize. We have knowledge, concept of the apple. That is the model in terms of machine learning. And deep learning is a different approach. Okay? So to learn something, we have a bunch of cases to generalize. But computer should be powerful. So deep learning actually addresses such a thing. So even though we never seen the new apple, it's an object, real thing, but we know this is an apple. Okay, we can eat. This is not an apple, okay, we cannot eat like that. This is called specialization. From the model, we can specialize. This is a model, this is an apple, this is a non-apple, this is something to it, so this is not. Classify. We can apply. So actually the machine learning uses the same technique. Train, and finally we can apply such a model, generalized model for the real problem. For object recognition, face recognition, and so on. So our thinking process is based on generalization and specialization. You already used a lot of the ways to you use this technique for a lot of things, including object-oriented concept. Object-oriented concept is also based on this one. From the real object, you can generalize to the class. After you create a class model, data structure, you can create the object in the memory. Okay, specialize. Then you instantiate the object. Finally, you are able to access such a data. So it's kind of the process of generalization and specialization in our real life information. Unfortunately, the ER diagram cannot represent such an important concept of the entity and relationship. Think about, for example, your customer provide the patient information and the doctor's information, receptionist information. All of them has name, ID, address, name, ID, address, name, ID, address. We need to keep the name, ID, address for each entity. But you may realize, no matter what type of person, it's a person information. If we combine into person, name, ID, address, we don't have to separate. Okay? That's the idea, that's actually object-oriented concept, right? To address such a problem in ER modeling. So we try to little bit extend such an idea to which is called the enhanced or extended ER modeling. So like this one. Even though you never seen the ER, it's called the extended. So extended or enhanced, it doesn't matter. Enhanced or extended entity relationship by combining the generalization or specialization concept. In other words, superclass and subclasses. Because you already learned the OOP, object-oriented concept, it's not very big there. Okay? So to understand such a concept quickly, go over. So for example, here, this is the design of an employee. However, employee is a person, and also employee has the different types of employee, like the secretary, technician, engineer. We realize that. So, here employee has the secretary, technician, engineer. For example, if the customer provide secretary information, technician information, engineer information, so combining this as a modeler, designer, I realized that all of them are employed. Why don't we manage it all together, common information like this one, employed. It's kind of generalized. So at that time, this is called superclass, as you know. And these are called subclasses. So enhanced extended modeling include superclass plus subclasses, the model. So this is called the enhanced extended model. So in this case, the general information are here, the employee, which means you already know one of the main characteristics of the OOP. There are several things. Inheritance means superclass, attribute of superclass inherit all of this automatically. So even though we do not mention the name, ID, address, or social security number, social security number, social security number, social security number. So this is called the super and subclasses relationship. At that time, we don't have to put all common information for each subclass. Instead, only one time superclass. Okay? So this is employee. At this time, question. What is the key attribute of employee? Social security number. What is the key attribute of a secretary? It's also social security number. What about the technician? Same thing. And the engineer? Same thing. So then, another question is, how many entities can you find here? One? Four? This is the one entity. Okay? But we are going to specify the subclasses and superclasses. It's a one entity. Okay? Yeah. It's all employee entities. Okay? So this is one entity. Then there are different type of the super and subclasses. So you will see D. D means disjoint. Disjoint means employee can be one of this only. Okay? At the time, this is a disjoint relationship. Super and subclasses relationship. Which means there is another type, which is overlap. So overlap. Any example of overlap?
You just had
Did?
car and truck.
Yes. Car and truck. Yes, this is one of the example of overlap. Overlap means we have a part superclass and subclasses. So some of the part manufactured part. Also same time purchased part. It may be possible because it's just one entity. Okay? So overlap. So if you know the such a characteristic, whether disjoint or overlap, you can specify D for the disjoint and O for the overlap. What about this? Part. It's a part, but it's not manufactured, it's not purchased. It may be possible at the time you can use the single line over here. Double line means it should be at least one of these. Manufactured part or purchased part or both of them because it's overlap. So you can specify the double line or single line, which means there are 4 different types. So disjoint total means it's the disjoint. And total means, so it should be mandatory, it should be one of the subclass. That is the disjoint total. Disjoint partial means, so this is one line, so we have the employee, but not belongs to any of the subclass. That is the partial. Overlapping means you allow multiple, but total means at least one of the subclass. Overlapping partial means you can be just a general employee, or one of these, or multiple of subclasses. So that is the overlapping partial. So you can use a D or O, single line or double line. And also one more thing is, mostly, if you know how to classify the subclass, you can specify such information over here. In this case, it's type of job. So such a job type can be also attribute of a superclass. Then finally, our goal of conceptual modeling is whether we are able to understand the meaning of such a organized data. So from this, so we are able to understand there exists employee and there are types of employee, secretary, technician, and engineer. And also, they are the disjoint, which means it cannot be both. But this is a single, partial. Means there are employees who does not belong to any of these, like that. Then I can understand the meaning of employee very clearly. So that is the purpose of the extended ER diagram. So next class we will see a little bit more details with the example. So mostly eventually we will have one of the example of this one. Question, last question. How many entities can you find here?
Two.
This is a one entity, person. There's no relationship. There's only super subclass, super subclass, super subclass, super subclass, super subclass. It's one entity. Okay? So next class. So we have a homework. Please finish the handout and submit it by the next week, Tuesday. Also, you need to submit on Canvas one example of database. The format is like the handout. Format is like this one. So you can create your own database and your answer. Then I'm going to select one of your submission as a midterm exam.
What does that do?